Hey y'all, today is Thursday and I'm continuing our notes with a second video. I'm on page 11 in your packet, and now we are going to do two-step inequality word problems. Some of these actually might be one step, but they're just inequality word problems. So let's get started with number 9. Sally is going furniture shopping and using her credit card. If her credit card has a limit of $2,000 and she is currently holding a balance of $763, how much can she afford to spend on furniture? So I've already highlighted the question that we're trying to answer. How much money can she afford to spend? So I've defined my variable. I'm going to use X every single time just because it's common, but X is the money that she has to spend. Okay, now what is some other important information? Well, she has a limit of $2,000, and she's currently holding a balance of $763. That means that $763 is like sitting on her credit card bill, right? So now which one of those is the total? If you said 2,000, you're right. So I know that that's going to go after my inequality sign. So it's just helpful to note what number is your total. It goes after your inequality sign, just like when we were writing equations, it went after the equal sign. Okay, so that means before the inequality sign, I need 763 and I need my variable. So she currently has 763 on her credit card. She can spend X amount of money. So we're adding that together because combined together, that has to be something compared to the $2,000 limit that she has. And it's important to note that it's a limit because can she go over that $2,000? No, she can meet that $2,000 at exactly $2,000, but she'd probably be better off if she was less than $2,000, if she was under $2,000. So because it's a limit, it's less than or equal to. So 763 plus X is less than or equal to 2,000. So if you think about it, the balance that she currently has plus what she can spend needs to be right at or under $2,000. So now how do I solve this inequality? Well, first things first, I'm going to draw my line through my inequality symbol. Just helps me see that I've got two sides, and whatever I do on one side, I must do on the other. Now, what kind of 763 is this? Is it positive or negative? If you said positive, you're correct. So how do I undo that? Well, I subtract 763. And I'm going to do that on both sides. Now on the side with the X, my 763 will cancel out, and I'm left with just X by itself. Was there any reason for my sign to change? Not when we subtract, so it's going to stay less than or equal to. On the other side, I've got 2,000 minus 763. I'm going to put that into my calculator. 2,000 minus 763 is 1,237. 1,237 what though? Well, $1,237. So don't forget to include your unit. So X is less than or equal to $1,237. And that's our answer. Okay, let's move on to number 11. We're just doing the odds on this page. Mrs. Hillard is purchasing a candy hearts to distribute to the 28 students in her math class on Valentine's Day. If she would like each student to get a minimum of 15 candy hearts, how many will she need to purchase? Okay, so I've already highlighted the question that we're trying to answer. How many pieces of candy does she need to purchase? Okay, now what else is important? Well, she wants to distribute to 28 students in her class, and she wants each student to get a minimum of 15 candy pieces, right? Well, which one of those is the total? I know it seems odd, but I would say the minimum of 15 is your total. That's the total amount that each student gets, right? Okay, so that's my total. And I also believe that that's the total because it tells me minimum. It gives me one of those key words for inequalities. So minimum, what sign would that be? Well, it means that the smallest number that each student would receive is 15, but each student might receive 20, right? So it could be more than 15 or it could be exactly 15. So minimum of 15 we know is greater than or equal to 15. So now on the other side over here, I need to somehow have my variable x, and I need to also have 28. So if she's distributing these candy pieces to her 28 students, would it make sense to say the total amount of candy pieces divided by the number of students? Does that make sense? Yeah, it does. Okay, is this an inequality that we know how to solve? It sure is. So in order to solve this, how do I get that x by itself? Well, it's connected to 28 through division, so I undo that with multiplication. So I'm going to multiply by 28 on both sides of my inequality sign. Now notice, I'm multiplying by a positive 28. Does my sign change? No, it stays the same, so it stays greater than or equal to. On the side with the x, the 28s cancel out. X comes down, it's by itself. On the other side, I need to type this into my calculator. 15 times 28, you're going to get 420. So 420 what? 420 candies, right? So that right there is our answer. X is greater than or equal to 420 candies. Okay, let's move on to number 13. Blake needed at least 225 votes to become president of his 7th grade class. If 3/4 of the 7th grade students voted for him and he won, how many 7th grade students could there be? Okay, so I've already highlighted our question that we're trying to answer. How many 7th grade students could there be? And I've defined our variable. X is the number of 7th graders. Okay? Now, what else is important? He needed at least 225 votes to become president, so that's important. And we know that there are, or if there are 3/4 of the 7th grade students voted for him, he won, right? Okay, that's all the important information. So really my important numbers are 225 and 3/4, right? Well, which one of those numbers is a total? What do you think? If you said 225, you're right. And the reason I know that that's the total is because I also have my inequality word at least right there, right? Okay, so how do I represent at least? Well, at least means could be more, right? Could be exactly 225, but it could not be 220. That would be less. So I know at least is greater than or equal to. So greater than or equal to 225 is what's going to go on that side of my inequality symbol. Now on the other side over here, I need a 3/4 and I need an x. So how do I put those two together? Well, 3/4 x. So 3/4 x is greater than or equal to 225. Is that an inequality that you know how to solve? It sure is. So in order to solve it, let's draw our line down our inequality symbol. And now I've got this x connected to 3/4, this fraction, through multiplication. So you could divide by 3/4, but what else could you do? You could multiply by the reciprocal. So what is the reciprocal of 3/4? 4/3. So I'm multiplying by 4/3. And I'm going to do that on both sides. Okay, so on the side with the x, my 3's cancel out. My 4's also cancel out, leaving me with just x. Now I'm going to ask you, was there any reason for my sign to change? No, there was no reason for my sign to change because I was multiplying by a positive 4/3. So my sign stays exactly the same, greater than or equal to. Okay, now on the other side, I have 225 times 4/3. I'm going to write that so I have two fractions. And I know 4 and 1 don't reduce, but what about 3 and 225? Well, here's a trick. I know that 2 plus 2 is 4, and 4 plus 5 is 9. So all of these numbers add up to 9, And 3 does go into 9. So I know that 3 will go into 225. I just don't know how many times off the top of my head. So in my calculator, I'm going to type 225 divided by 3, and I get 75. So I know that 3 goes into 225 75 times, and 3 goes into 3 1 time. So now when I look at this, my denominators are both 1. That means my answer is going to be a whole number. Okay, so I'm going to ignore my denominators. Now I'm going to multiply my numerators together. So 75 times 4. Well, 75 times 4, if you put that in your calculator, you get 300. So x is greater than or equal to 300. 300 what? 300 students. So there are at least 300 students in the 7th grade class. There might be more, but there are not less. Okay? Last one, number 15. Maggie is stocking up on chicken noodle soup for the winter season. If each can is $1.25 and she has a $2 coupon, how many cans can she buy if she can spend no more than $30? Okay, so I've already highlighted the question that we're trying to answer. How many cans can she buy? So my variable, I chose X because it's common, represents the number of cans. Now, what else is important that I might circle? Okay, well, each can is $1.25. Notice that keyword, each. What do you know about 1.25 in your inequality? It needs to be attached to my variable. Okay, so let's go ahead and attach it to my variable. We know we're going to have 1.25x, right? Okay, well, what else is important? She has a $2 coupon. Well, what do you know about coupons? If you present a coupon at the grocery store, they take some of your total off, right? So it saves you money. So how do I represent that that coupon is saving her money? She's not having to pay as much. Well, I'm going to subtract. So minus 2. Okay. Now, what else is important? Well, she can spend no more than $30. So what inequality symbol would be no more than? Well, it means that she would be perfectly happy spending $26, less than 30, right? But she might not have $31 in her pocket. So she cannot go over. So less than or equal to seems like a good fit. Okay, so that is a 2-step inequality that you should know how to solve. So let's first draw our line down our inequality symbol. And remember, we're trying to get that x right here by itself. And I want to start farther away from the x and work my way in close towards the x. So is the 1.25 or is the negative 2 farther away from the x? If you said negative 2, you're correct. So how do I undo that negative 2? Well, I add 2. So I'm adding 2 on both sides of my inequality symbol. Now on the side with my x, my 2's will cancel out and I'm left with 1.25x. Now adding 2, does that give me any reason to change my symbol? Oops, sorry y'all. Did adding 2 give me any reason to change my symbol? Absolutely not. So it's going to stay less than or equal to. But on the other side, 30 plus 2 is 32. Now, how is 1.25 connected to x? Well, it's connected to x through multiplication. So how do I undo that? With division. So I'm dividing by 1.25 on both sides. Okay, so on the side with the x, the 1.25's cancel out, and x is by itself. Did dividing by 1.25 make me change my symbol? No, I was dividing by a positive, so it stays the same. Now on the other side, I've got 32 divided by 1.25. And when I put that into my calculator, I get 25.6. So x is less than or equal to 25.6 cans, right? Okay, so let's think about that. Have you ever been able to go to the grocery store and buy 0.6 of a can of chicken noodle soup? No, you can't buy partial cans. You can only buy whole number cans, right? So, because this is less than or equal to, if we round up 26 cans. She's going to go over her budget. She can't do that. So the maximum number of cans that she can get is 25 cans. So at most, she can buy 25 cans. You have to round down. So that is the end of our notes for today. I will post the homework in Google Classroom. Y'all have a good day.